Evening, I'm Spot On Weather meteorologist Matthew Euler. Welcome to tonight's video. Hope everybody had a great Thanksgiving yesterday, by the way. And tonight's video is called Location, Location, Location. And yes, you're going to know exactly what I'm talking about as far as the positioning or location of specific atmospheric features and what that potentially could mean. Let's first start things off by taking a look at the east-based versus the west-based North Atlantic Oscillation, NAO. Now, I know there's been a lot of talk lately, and we've seen the model output, many of us, that we're heading towards a negative-based NAO, or North Atlantic Oscillation. All right, and in general, what that does is it tends to bring colder than normal temperatures into the eastern United States. With a positive NAO, you typically get warmer than normal temperatures in the eastern United States, okay? But did you know that there is a difference? Now, this is courtesy of the North Carolina Climate Office out of NC State University. There's a difference in the NAOs and subcategory-wise between east-based versus west-based. All right, so the first thing we're going to look at here on these two graphics, we're going to look at the height anomalies. Anywhere where you see orange and yellow coloring, that indicates, or reds, that indicates above normal heights. If you see a purple coloring or blue coloring, that indicates below normal heights. We're going to examine the first one up top here. This image here shows a negative-based NAO. Now, what is a negative-based NAO? It's one in which the upper level ridge, the strongest heights, are generally located further eastward, away from the North American continent, generally east of Greenland. That's a negative or east-based negative NAO. On the other hand, look what happens down here in the bottom. You have a west-based negative NAO. Now with this, you get more of the strongest parts of those upper level ridging or the higher heights is now located to the west of Greenland with a west-based negative NAO. And in the west-based negative NAO, you typically find the cold and the snow, they're not focused not only over the plains and Midwest, but now they tend to move practically all over the eastern U.S. And then additionally, a big difference between the east-based negative NAO and the west-based negative NAO is that storm track is now favoring the east coast with a west-based negative NAO. When you have that anomalously higher heights, the upper level ridging, the greatest heights associated with that ridging to the west of Greenland. And then that generally also with west-based NAO, it gets conditions more favorable for east coast cyclones and colder than normal temps in the east with west-based, but then it tends to be drier back towards the Midwest with a west-based negative NAO. Coming back up here, the east-based negative NAO, I forgot to mention generally that, again, I mentioned about the strongest heights associated with this upper level ridging, the negative NAO across the North Atlantic being east of Greenland with an east-based negative NAO. But I did not mention that the fact that the Midwest and the Ohio Valley, they tend to see the lowest heights and generally tends to focus the coldest air in the plains, the Midwest, with a east-based negative NAO when you have those higher heights east of Greenland. West-based negative NAO, those higher heights are working their way further to the west of Greenland. Okay, so that's a big difference in location, location, location as far as the outcome of what we could see. Look at this. These are the temperature anomalies in degrees Celsius. This is the east-based negative NAO, okay? And this is the west-based negative NAO, all right? So when you're looking at the temperature anomalies, if you see purple coloring or blue coloring, that indicates below normal temperatures. When you see the yellows and the lighter greens, that indicates above normal temperature anomalies in degrees Celsius, okay? So with the east-based negative NAO, look at where the cold is focused. Oh, wow, look at that. Over central Canada, back towards western Canada, over the parts of the Pacific Northwest, the northern plains primarily see the coldest temperature anomalies with a east-based negative NAO. And look at the east coast remaining mild. See that? From the Carolinas northward to Virginia, right on up into New England. It's remaining above normal as far as temperature anomalies with the east-based negative NAO. With a west-based negative NAO, here are your anomalies in the bottom left. And look at this. Look how far east these colder than normal temperatures get all the way to the east coast of the United States. You do have a core of a very cold air mass from northwestern Canada working its way southeastward to the Dakotas and dropping down to the central U.S. But look at the purple coloring, that shading, going all the way to the east coast with a west-based negative NAO. And here are the anomaly numbers, by the way, here on the right. So big difference between an east-based negative NAO versus a west-based negative NAO. Again, this is courtesy of the North Carolina Climate Office, which is located there at North Carolina State University. I wanted to show you this, okay? And now I'm going to show you the upper level forecast of 500 millibars. I'm going to show you the EPS and the GEFS and what that means for the future. Okay, so here is the forecast going out to 5 December 2022. This is the EPS on the left. This is on the right, the GEFS, okay? I'm showing you anything in the brown coloring or the maroon coloring or the oranges, that's above normal heights. Greens, blues, below normal heights. What's the importance of these anomalous heights, okay? When you have a brown coloring, orangish coloring, this maroon coloring, that indicates that you have an upper level ridge in place. What does that do? That tends to favor drier and warmer, milder temps. When you're in the blue areas or even these green areas and you have anomalously lower heights, that tends to favor more unsettled weather and cooler than normal temperatures. All right. So what do we have going on here? What do we have going on here in the North Atlantic as far as this negative NAO? Where are the highest heights? Where are the highest heights in association with this ridge? According to the European EPS, okay, for the 5th of December on the left, is showing it to the east of Greenland. To the east of Greenland. That, again, would go back to our east-based negative NAO. And look at this. Mild temperatures on the eastern seaboard up to New England. All right. What's the forecast over here on the right for the GEFS? Showing where those highest heights are, generally to the east, in agreement with the EPS for 5th of December, the forecast, showing those higher than normal heights east of Greenland, which indicates, again, the east-based NAO temperature anomalies. Here it is, where your highest heights, east of Greenland, east-based negative NAO. Where your coldest temperatures, back in the Midwest, to the Northern Plains, even back in the parts of the Western U.S. You see it, okay? What about moving now to the 8th of December? What's going to happen with that anomalous ridge there in the North Atlantic? Okay, so by the 8th of December here, EPS on the left, again, and GEFS on the right, we're seeing that upper level ridging is now moving further toward the west. It's not only over Greenland, but the ridge axis starts expanding a little bit further to the west of Greenland. So there's a good potential that this east to west orientation of the ridging could actually result in higher heights over time being to the west of Greenland. Why is that important? Again, west-based negative NAO temperature anomalies. Cold extends all the way from the Rockies to the east coast. Those milder temperatures are no longer there. Those above normal temperatures are no longer there on the east coast within west-based negative NAO. And there it is. It's right here around the 8th of December. We're starting to see signs of the transition from an east-based negative NAO to a west-based negative NAO. And then look over here, the GEFS model showing a similar situation where the ridging is extending more east to west, further towards western portions of Greenland. So this is going to be real interesting to watch what unfolds over the next 10 days. I'm really intrigued by this. All right, now let's move over to the Pacific side. All right, and I talked about this before in a previous video. The sweet spot. If you go back and watch my video called The Sweet Spot, I was referring to the position of the ridge axis when it comes to the Pacific side. All right, when you have a ridge axis that goes pretty much right along the coast from the Pacific Northwest to the U.S., up along the Canadian coast, the west coast of Canada, basically the west coast of North America here, and you have that trough further to the west, okay? Got that ridge axis, so most importantly, right along the coast. Look at this, ridge axis right along the coast, right? This resulted in extremely cold temperatures, anomalously cold temperatures from the central to the eastern U.S. over that time period that this occurred. Specifically on the 20th of November, one of the coldest days of the period. But the whole United States was below normal. Temperature anomalies below normal And that was because the location of this ridge axis being right along the immediate coast. What's going on right now? Looking at the Northern Hemisphere view here now, this is EPS forecast for the 3rd of December on the left. This is the GEFS forecast at 500 millibar height anomalies on the right for the same period, 3 December 2022. So where is our ridge axis here? EPS here on the left showing the ridge axis poking up into the Kodiak area, into western portions of Alaska. But look, it's too far west. That ridge axis is too far west. The orientation of the ridge axis is basically from southwest to northeast. And look here. When you want the cold in the eastern U.S., you want that ridge axis pretty much south to north. So the direction, the extension of the ridge axis, orientation of it's just as important as the positioning. Here we don't have that. This is 3 December. So what does that do when this ridge axis is this far west? Oh wow, it produces this trough. This green coloring here, this trough is also further to the west into parts of western and central Canada, extending southwestward into the Pacific Northwest. Well, whenever the trough digs here in the west, it's going to result in higher heights downstream over the central and eastern U.S. So now we get more of a ridge configuration for the Midwest to the East Coast, with the ridge axis being too far to the west. Looking at the forecast here on the right for the GEFS for 3 December. This is a little bit more of a south-north orientation, but the positioning again is not what you want. It's not ideal for colder temperatures in the lower 48, okay? Look at this. It extends into western Alaska on the GEFS forecast. And then you see colder air. You see that troughing downstream. Western and central Canada down into the northwestern U.S., northern plains even, all the way down to California with this configuration with the trough axis. Downstream of that, you pump that ridge up. You're pumping the ridge. And that baby's going to hang on tight. It's not going to allow that cold air to really ever reach the east coast of the United States with this kind of upper air configuration. That ridge axis so critical. And when that ridge axis is too far west, it results in that negative Pacific North American pattern, PNA. And there you go. Let's take a look at the Teleconnections forecast. I'm shortening things up tonight. Normally I would do a Teleconnections, a full-blown video, but due to time constraints, I'm going to have to go with a more abbreviated version tonight. But in general, here is European Ensemble Prediction System, EPS. All right, we're going to look at 4 main teleconnections of interest tonight. I'll also delve into the polar vortex to take a look at that forecast. I'll also delve into the MJO. I think these are the big players, okay? We look at the AO forecast here, the European EPS. The green line is your ensemble mean. So it's the average of all those 50 model members, all right? So I pay attention to this green line for that mean or average of all the model members, showing a negative AO, okay? We're in we're negative territory right now, just slightly here on the 25th of November, but we're going to dive deeper into even stronger negative territory by the 29th of November. Kind of recover a little bit around the 1st of December, but then we're going to remain predominantly negative AO. Looking at the NAO here on the right, upper right, same thing. We're diving deep into a negative NAO pattern in early December, specifically from the 2nd right on down to the 6th, 7th of December. And the European EPS for the NAO, 50 perturbed members, doesn't show much recovery to this. It's a negative NAO all the way through 10 December. Looking at that European EPS EPO forecast, 50 perturbed members, showing a negative trend of this. Now, last time we got really cold, yeah, we had a really, really sharply negative EPO. But again, this was the ridge axis position, okay? It was further east than what's being forecast. And that's your big difference. If you can get that negative EPL like this, plus that ridge axis and that sweet spot right there along the west coast of North America up into the west coast of Canada, then things are going to be different as far as the temperature regime. Looking over here on the right, we see that PNA. This is a problem here. This is called destructive interference. One of the teleconnections is not, because I can look at this, right? I can look at this. I can label this. I could say, okay, negative Arctic oscillation. That should favor cold temps in the east. I can look at this on the upper right. A negative North Atlantic oscillation should favor colder temperatures in the east. Now, again, that depends on whether it's an east-based or a west-based negative NAO, as I already covered. And then EPO negative. Oh, yeah, that should favor a colder than normal temperature regime in the eastern U.S. So I got cold, cold, cold. Uh-oh. Not this one. We're gone negative on the PNA, and it's pretty decent amplitude here of the negative phase of the PNA. Uh-oh, negative PNA. What does that mean? That means I have a trough in the western United States and a ridge in the east. So this would indicate warmer temps in the east, okay? Cold, 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 warm. And that is an example of destructive interference between the teleconnections. GEFS Teleconnections Forecast, just want to show you another ensemble prediction system, kind of like what it looks like. Generally, the AO, Arctic Oscillation, right on into early December. Wow, remaining negative all the way to the 11th of December, according to the GEFS. The Arctic Oscillation AO, negative. The NAO also dipping and tanking, negative. Pretty significant amplitude at -3. Okay, and then you've got the negative EPO down, pretty significant amplitude here on this as well. The GEFS forecast for the negative EPO all the way down to a -3 to close out November into the 1st of December. And then you do see a recovery of that EPO by the 6th and 7th of December to where it's more neutral. And then here on the bottom right is again showing you the Pacific North American GEFS forecast. Again, -3 amplitude here. And then it finally recovers closer to neutral according to the GEFS around the 5th of December. As far as the European ensemble prediction system, no, it's not recovering to neutral on the 5th of December like the GEFS. Okay, there's a difference there. The EPS keeps it negative pretty much all the way through the 10th. Slightly closer to neutral, but still negative nonetheless through the 10th of December, whereas this GEFS forecast, it brings it up more significantly closer to that neutral territory by the 5th. So a little bit of difference in the modeling as far as timing. But I'll tell you what, again, we can look at it the same way we just did with the EPS, the European cold, negative AO, cold, NAO, negative. Again, depending on where those highest heights set up, whether they're east or west of Greenland. And then the EPO, cold, it's a negative. And then this one could destructively interfere. So when I talk about destructive interference, again, that generally means that one of the teleconnections is not aligning with the other ones to favor a specific solution. So it's kind of like an opposite reaction, so to speak. And sometimes the one teleconnection can overpower these other ones, specifically if it gets fairly strong. Now let's take a look at the stratospheric polar vortex forecast. This is the latest as of today, the 25th of November. Now this is the 18Z GFS run here on the left. And this forecast, by the way, is for the 8th of December here for the GFS on the left-hand side. These white solid lines indicate your height contours at a 30 hectopascal, 30 millibar level, well above where we live here at the Earth's surface. And you would never think that what happens way above us would really matter to our weather here on the Earth's surface, but it really does, specifically in the stratosphere with the temperature profile. Generally what we're seeing is, two specific lobes here being enclosed. One generally over portions of far northeastern Canada, the other one generally over portions of, that would be over there closer to Europe. All right, so this is not a sign of a strengthening polar vortex, okay? You don't see a circular symmetrical pattern over the North Pole. You don't see one specific circulation. Instead, we're seeing multiple circulations again. We see a stretching out of these white high contour lines indicating elongation. GFS continues to advertise for a weaker polar vortex. Looking at the graphic here in the middle, this is the European. This is at 50 hectopascal levels. These are the geopotential heights and the anomalies in meters showing, wow, extremely above normal heights close to the stratosphere here in association with that tropospheric upper level ridge, the west base or the east base negative NAO through the 5th of December. Here is the forecast for the European. But in general, again, we're seeing this elongation shape. See the dark solid black lines here? That indicates your height contours, and they're just really stretched out again like a rubber band here. So that's a weak signature for the polar vortex. And then finally, the GEFS, the GFS ensemble here on the right. Look at how this is just really stretched looking. These are isotherms, lines of equal temperature. Green is very cold temperatures in the stratosphere. This is up at 10 hectopascal level as well. And that orange coloring is significant warming in the stratosphere in this particular location. Real interesting here. Is there really going to be a stratospheric warming? That remains to be seen. Too early to tell on that, but Again, elongation, all right? Look at the shape of this green coloring. See how it's stretched out? It's more elongated or oval. So any way you cut this, this is 9 December forecast, by the way, on the far right of the GEFS. This is the 5th of December forecast. This is the furthest European goes out. And this is the GFS. This goes out to the 8th of December. So at least through the 8th to 9th of December, we're looking at a weakened stratospheric polar vortex in all model projections. What about that Madden-Julian oscillation forecast? Let's take a look. This is the GFS ensemble forecast. This is the mean. This is the average, this solid green line of all the yellow. See those yellow lines? Those are different model members. But generally what we're showing you is the average mean of all the ensemble members is the green line. And so we're currently in phase 7. We're working our way towards briefly into phase 8, but significantly weakens in magnitude as it heads back to the inner circle here. It's that null phase as we head into portions of early December. And then it tries to come right back out into phase 6 here. You see this little thin line here? That represents your week 2 forecast through the 9th of December, showing, I mean, look at this. This thing's trying to go right back out into phase 6. I'm going to show you that's very common in a La Nina winter time situation, and I'll show you why in a minute. And then here on the middle center diagram is a forecast from the GFS. That's that aqua line here, that bluish line, showing the very similar, we're in phase 7 now, where the convection's enhanced in the Western Pacific Ocean. And it's going to rotate basically into phase 8 briefly, and then work its way back into the null phase, that small inner circle, by the 9th of December. And then over here on the right, I'm showing you the CFS climate forecast system, CFS 30-day forecast. You notice where the focus is with the CFS? It's way over here in the Western Hemisphere in Africa in phases 8 and 1, and even rotating to phase 2 towards the Indian Ocean by late December. So, I'm really questioning this particular, output by the CFS. I like to show it just for comparison purposes. But, for these two to be in agreement up here, and most of the other models I looked at are as well in phase 7. And then with the CFS, you don't see anything up here at all. That just makes you scratch your head a little bit, right? Whether it's reliable or not. Here are the MJO temperature composites for the months of December, January, and February. Blue coloring on these indicates below normal temps, and then orange coloring above normal temps. Bottom line here is, the forecast is calling to go into phase. We're in phase 7 now, but we're working our way to phase 8 in early December. What would phase 8 do in early December? Look at this. That would definitely favor the colder air being east of the Rocky Mountains all the way to the East Coast. Whereas, phases 1 and 2 are also colder phases of the MJO in the winter, December, January, and February. Phases 3, specifically 4, 5, 6, those are very warm phases of temperatures in the eastern U.S. Of the MJO. Here is why, we look at this and we say, okay, geez, how much time is it spending over here, the enhanced convection? How much time is the MJO spending over in phases 6 and 7, enhanced convection in the Western Pacific Ocean? All right, do you see it really in any of the other sectors here? Phases 1, 2, 3, 4, 5? Do you see it in 8 really? No. Look, do you see it over here in that diagram in any of the other phases, 8 through 5? Not really. What about over here? See, the reason is because during La Nina conditions, you have warmer than normal water temperatures across the Western Pacific. Now that favors rising vertical air motion. You can see that represented here by this up arrow. And then you have sinking air motion over cooler than normal waters across the equatorial eastern Pacific, okay? Cooler water generally favors sinking vertical motion. So it's one big circulation cell. See this? Where you get rising air over the Western Pacific. Oh, and that is perfectly in line with phases 6 and 7 right here. Why are we spending so much time in phases 6 and 7? We're in a triple dip La Nina. The circulation's been set in place already for 2 previous winters. Now we're just in winter 3. Upward vertical motion, rising air, enhanced convection, Western Pacific. All right. Sinking air motion, Eastern Pacific over cooler water. All right. So I just wanted to kind of show you the La Nina vertical circulation pattern correlates nicely to MJO phases 6 and 7. Now, speaking of La Nina, I just wanted to show you a brief image courtesy of Levi Cowan at tropicaltidbits.com, generally showing you that we're sitting at a minus 0.931, minus 0.93 degrees Celsius below normal Temperature anomaly in that Nino 3.4 region, that is going to equate back down to a weaker La Nina. Last week I did the video on teleconnections last Friday night. If you haven't taken a look at it, take a look at it, and you'll notice that this value was around negative 1.01. So the temperatures have warmed slightly. You kind of see the trend here, this blue line, how it's kind of going back up, how it dipped just slightly below negative 1 degree Celsius anomaly here around mid-November, but now it's moved back up by the end of November to the weak category. We briefly went moderate, low and moderate, and now we're back to the weak La Nina category. All right, final thoughts for tonight's video. All right, we are looking at an east-based negative NAO through the first week of December. Now, this is resulting in the coldest temperatures back into the Midwest, back into the northern plains, back into the western U.S., well northwest of the mid-Atlantic. Now, there are signs of a west-based negative NAO taking place at some point during the second week of December, where those higher heights and the ridge axis extends further just to the west of Greenland. Now, that could potentially allow the colder air to slide further east to the eastern U.S., to the east coast. At some point during the second week of December, the GEFS, the European, and the GEFS models, I've showed this to you in the previous slide, they all point to a continued weakening of that stratospheric polar vortex, stretched out, elongated. I'll tell you what, this stratospheric polar vortex just has not been allowed to get strong to this point. And so a weaker polar vortex heading into the winter season, meteorological winter begins December 1st. You got to wonder what's going on here, how long this stretching and elongation is going to occur. There's been talk on social media about a potential split. I think it's just a little bit too early to tell just yet if there's going to be a major sudden stratospheric warming and a split of the vortex. A little bit premature in that, even though some of those models are projecting it. All right, so we have a negative Arctic oscillation expected, a negative Eastern Pacific oscillation, the EPO expected as we head into early December. But we have a negative PNA. We got that ridge axis over, the ridge axis over the northeastern Pacific. It's too far west. It's too far west. And that's promoting that downstream trough further west into the western U.S. And so that then pumps the heights up east of that, long wave ridge or the long wave trough or short wave trough over of the western U.S. That pumps those heights up east of that into the eastern U.S. And you get that. Everybody's talking about the ugly term I can't handle in winter, and that's southeast ridge. That thing just haunts my dreams at night, okay? Because I really like colder weather in the winter. But that ridge, sometimes, various MJO phases, let's say phase 3, if I'm in MJO phase 3, or actually, phase 4 and 5, I meant. If I get MJO in phase 4 and 5, that is my worst nightmare for the winter. Because that most likely means I have a southeastern ridge on steroids off the southeast coast. And now all the cooler air back to the west just can't get here. It's like running into a roadblock, okay? Those coldest temperatures remain well off to our northwest. That negative PNA, that positioning of the ridge over the northeast Pacific matters. So right now we look at that negative PNA, and the stronger that PNA goes to the negative side, the more influential that could potentially be with that trough remaining over the western U.S. for a longer period of time. So that's something we got to watch. But as of right now, today's models, 25 November, we could all wake up tomorrow. You know how these models change from day to day. 2 days ago, it looked like the cold was going to move further east much earlier into December, after the 3rd of December, and now that's been delayed. You occasionally see these colder periods, but nothing long lasting. Temperature variability, I will say though, is still a possibility. It's still going to be possible for the eastern U.S. and mid-Atlantic. Okay, we will see milder temps for the most part through early December, but then we will see some occasional stronger cold fronts able to kind of weaken or flatten that ridge off the southeast coast. So we could expect more of a brief colder period, then again, emergence back into milder temps. When I say milder temps, I'm talking 50s. I'm talking 60s for the mid-Atlantic as we head into early December. That main storm track also is very critical where that baroclinic zone sets up, that zone that separates very cold air from milder air to the southeast. Okay. If it's further to the west toward the Midwest or northwest toward the Midwest, if it's over the Midwest, it's like perpetual no good for people that want winter weather on the East Coast because you just have constant warmer air advection on the east side of cyclones. The trough digs in the Midwest. That means that the heights rise east of the trough over the East Coast, and yeah, you remain fairly warm. All right. This is what I'm thinking right now. Again, this is based on what I'm seeing today, the 25th of November, 2022. Hopefully you enjoyed the video tonight. And that's all I've got for now, everybody. Until next time, take care and God bless everyone.